This is the third part of 3.2 and also the last part. So in this section, I just wanted to show a couple of examples that is a bit different from so-called graphing polynomial functions. But in fact, it's the same thing. It's kind of just talking about something reverse. Now, for example, now the polynomial has these roots, zeros, right? Or roots, zeros, same thing. And then if when x equals to 1, the px equals to 5. The question is, you need to write an equation, right? So far is either the equation's given or the sign graph is given or sign diagram is given, and you graph. Now here, it is the different information is given. You got to write out the equation, write the equation. So now, of course, from this information, we can write it out. This equation should be looking at that. The only thing is that we do not know the a. All right, so in this case, then we can use this condition given, and so when x equals to 1, px equals to 5. So then that means this all equal to 5. And then from here, you can calculate a, which is 5, negative 5 over 4. So then the equation is like that. This is rather very straightforward, okay? Now the next one is that this information is given. And then the graph is given. See, the graph is given. And then we needed to write out the equation again. So now we need to write an equation. So now again, from this information, we have a 0. So that means x plus 4, right? And then your multiplicity is 1. Oh, great, good. So that's 1 here. And then you have another 0, then that is negative 2. So then it's x plus 2. And then here says the multiplicity is 2. And then you have last one is 1. So x minus 1. And then the multiplicity is 1. Okay, very good. And then after that, again, is we needed to figure out the leading coefficient. So then our px, at least now we can write out in this form. So again and again and again, it is just a matter of fact of figuring out what a is. All right. Now the graph is given, so we can see our y-intercept here is 0 and negative 3. So therefore, when x equals to 0, x equals to 0, x equals to 0, x equals to 0, and then this is negative 3. Then from here, we can calculate the a. Same thing as that. So this one is, this point is given, so 1 and 5 is given. Now this one is from the graph. You're going to locate one of the point, which is 0 and negative 3. Either way, plug the point in, then you can calculate the a. Now the last example I'd like to also have you to take a look is this one. So this one is just given in a very general form. So this is, again, this is a factor form of the polynomial. Now how many zeros is here? We got a, we got a b, we have a c. So we got a and b and c. All right. Now they're also given to you because if only a and b and c, we have no idea where a and b and c is. Are they positive numbers? Are they negative numbers? So thankfully, of course, they have to give us this information. So that means from here is a and b are negative numbers, and also a is smaller than b. Now c, on the other hand, is a positive number. So you can use this called the sign diagram or just even number line. So just use a number line. So then we got a 0 here. And then we got a B. And then we got an A. And we got a C. Right? So this one from here, you can already sketch the graph. But if you want to, of course, because it's talking about graph, then it should be on the Cartesian plane. So then from here, we can just say, okay, all right, let's just draw a Cartesian plane first. All right, but then our intercepts are as such. This is not our intercept, sorry. So our intercept is 3 of this, A and B and C. All right, so that's our intercepts. Then where is our y-intercept? Okay, well, y-intercept we go bring into back to this factored form. It's given. That means this is 0, and that is 0, and then that is 0. So that means negative a fx or y equals to negative a multiplied by negative b to the power of 2, and then negative c. So then this is a negative, and this becomes positive. So in the end, it will be a negative number, and then that is a, b to the power of 2, and c. So that is negative. So somewhere here, there is a 0 and negative a, b to the power of 2, and c. All right. Okay, so now we got all these things, and then let's see what can we draw? A sketch. Now again, this is x power 1, 1 power 2, and power. So this is, the total is 4, right? So this is, the degree is 4. Leading coefficient is a positive number, so we do know this will be something over there. Oh my gosh, what's wrong with my pen? And it will be something over there. So then we can start knowing the end behavior. And then at A, this is going through for sure, because its multiplicity is 1. And when we're going to B, the B will be bouncing, so it will not go cross, so it will bounce. And then we would have to go down to our y-intercept. I got a y-intercept, it's so badly looking down here. And then going up there, I would go through our C, right? Because this one is also power of 1. So that's my graph. Looking different than this one, but there's nothing I can do about it because I do not know the A and B and C, how much. Of course you can say, well, that could not be true, because if this is 2, that is negative 2, this is negative 1, and that is positive 2. You can somehow calculate it, so not be as bad as my sketch. Nevertheless, so that is my graph. So this is my graph. Going over that way. So this is my graph. And then the next question is, what is the solution for fx is larger than 0? So fx is larger than 0 is this part. This part is larger than 0. And this part is larger than 0. So that means the x value has to be smaller than A, larger than C. Then that would make fx larger than 0. Now what is the smaller or equal to 0 for fx, for y value? Then it's down here. This is all down here. These parts all the y value is either smaller than 0 or equal to 0. So that means in between A and C, satisfy this inequality. Outside of A, outside of C, satisfy this inequality. All right, so I think that basically we have covered everything we need to cover for 3.2. Now, estimating zeros of a polynomial function. This one, we do not need to worry about it. Okay. So don't worry about that. And graphing polynomial function with a graphing calculator, we don't use graphing calculator anymore. We're just using the graphing software. So don't really worry about this either. Okay.